The overall goal of this procedure is to describe a method to express fresh pore solution from a plastic cementitious paste system using a stainless steel pressurized nitrogen gas filter, and to measure the pore solution chemical composition using an energy dispersive X-ray fluorescence benchtop spectrometer. The chemical or ionic composition measured by the XRF can be used to calculate the electrical resistivity of the pore solution, which can then be used in conjunction with the electrical resistivity of concrete to determine the formation factor. Since XRF is a commonly used device in the cement industry, this method could potentially enable cement manufacturers to use a tool already at their disposal to provide more information about the cementitious pore solution, such as the ionic composition and resistivity, for numerous applications and at a lower cost and testing time than conventional methods. Essentially, this method could extend the applications for the use of an XRF for a variety of cement and concrete studies. To begin this procedure, check that the individual components of the pore solution extractor are clean and dry. Then, assemble the pore solution extractor according to the manufacturer's instructions. Check that there are no visible deformities in the cellulose filter. Next, add the fresh paste into the main chamber. Make sure to leave at least 1 centimeter from the top free. Then, connect the pore solution extractor to the nitrogen.